working on equations. Two different types of apples.
I'm going to ask you to share that.
I'll give an answer in the
You work in school?
It's crazy to see.
That's what my students do.
Over there.
That would be great if you would share that, because that's one of the meetings.
Yeah, so this is kind of the same. He modeled it different. Oh, really? With 8 here and move 5. Sure. And he showed here and move 5.
Yeah.
So we felt that was similar. And then I changed it a little bit. I had 8 positives, and then I added 5 negatives, and then canceled the positives and negatives. And end up with the same.
Okay. So when we come back together, will you, so show me one more time that second one.
Oh, just the, it's kind of the, you know, from the CFP curriculum, the idea of the positive and negative chips. So I changed the subtraction to an addition problem and adding a negative. And then you have your chips, and then you cancel the positives and the negatives.
Me too.
Left with the
What about that model down there? Talk to me about that one.
It's the same as the you just explained the set values.
So would that model work if it was all positive?
Yeah.
So thinking about the way we got that model, would it work if they were all positives and not some positives and negatives?
If these were positives?
Yeah. So is there a meaning of subtraction?
Well, what I wrote down was instead of subtracting a positive number, I added a negative number. I'm not sure if that answers what you're saying or not.
No, and I'm just being curious about how you're thinking about it, and also thinking about the meanings of subtraction that become important.
Well, because then he went to, you heard him talk about the inverse separation. And we're talking about just how, what's the difference between me adding a negative number and him adding the two same numbers? Because at first I thought, oh, he's wrong because he's adding. But then I ended up adding also.
And you're really then calling out the relationship between addition and subtraction.
Yeah.
That's from math geniuses.
Just kidding. So I'm going to leave you guys with a question. So if you were to see this model on the student's table, okay, and it's all positive numbers, is there a meaning of subtraction that they might be considering? And I'm just going to leave that there and let you guys think about that.
That model was, there's 8 tiles, and take away 5.
Okay.
3.
Okay.
And then he had a similar variation on that.
Could you add
just add
5
8 total tiles
here
and
and make me
color them differently, and so
Negative.
consider presentation.
This right here,
Well, we know that it's all 8, and we have the 5 that were taken away, so we can clearly take those away. We're left with 3.
Okay.
8, yeah.
And same thing for those two as well?
5 negative.
Was there another meaning of subtraction that you guys were thinking about?
Even sharing out line, I think I overheard you guys share too. Sorry, go ahead.
Oh,
Just the
8 positives. Yep.
Well, they might come up with an idea, but they might not know it's negative.
So I'm going to
There's 8 total things.
show me a model of what that
So many
might
different things.
look like. There's 8 positives.
I mean, there's 5,
So is there something you could do with that model where they're all positives, but not showing any subtraction? Think about that model.
Well, Even if they did.
So think about that model, and is there a meaning of subtraction you might be
Is it
able to
what
show?
they're
And I'll leave that question, same question I asked over there. What is that question number to say?
You got it?
Really, this is, like I said,
This was a little bit
explaining you what the model that shows the negatives you had.
She said if they're all positive.
Is there another meaning of
And
subtraction?
so if it's a positive, these are stuff we have total.
Okay, so with that in mind, is there something that you could do with that model
Give a model like that.
where all of those are positive? So you might have to show,
Came up with that.
Well, I guess
That just shows you the other.
might have similar connotation to that piece.
you have 8 times the
How much you could expect in high school.
taking 5 positives away, all these 5s are going to jump these away.
Like, literally the same things you said.
Yeah, so if this was your.
Number of powerful.
Let's assume there's all
Sorry,
positive.
flashback.
Is there a meaning of subtraction that a student might be talking about if they do this in the classroom? And I'm gonna leave that question. And I'll be honest, I've asked the same question to two people, and I'll let you guys think about that.
I don't know.
So if there was 8 positives and 5 positives?
Check that, what do you guys think about it?
I didn't get it.
Well, we're gonna talk about this. And I'll be really transparent that like right now I'm going out all the meetings that's in common core that falls out. So we're gonna come back together and fix that. Because it's tied to what you're doing. All right, I'm gonna bring us back together here. I can pull us all back together. So a couple of things. We're gonna debrief this, but I want us to hop back and forth between having your participant hat on and your teacher hat on to be thinking about a couple of pieces here. One is I want to be transparent about what my core math idea is. So depending on, I know districts do this a little bit different. You might have different words for things, whether you call it an essential question, whether you call it a learning target, whether you call it a core math idea, whatever you might call it. So what do you call it here at Uniclaw? What are you posting for your students? Learning target? Okay. And then do you think about success criteria in terms of what might the student do to give you evidence? Okay. So help me be really specific with your language. So if I call it something else, don't hesitate to say, well, we call it a learning target here, because I want to make sure that I use the same language that you do. In terms of my goal here, that core math idea, which is the mathematical idea that I really want us to dig into, and I wrote it as a question. What are the meanings of the operations? And specifically, we're digging into subtraction, and then we're going to think about division in just a moment. Okay? So I want to be transparent with you around that, the same way you'd be transparent with your students about what you're wanting them to be thinking about in the classroom. And we're going to be tying our digging into the meaning of the operations to the Common Core standards. So we're really thinking about what are those meanings of subtraction mathematically, and then how are they being called out in the Common Core. So that's one piece. I also wanted us to take just a minute to think about that structuring of student talk before it's too far in the past and we forget some of the nuances. So just now you had a chance to finish that part where you're comparing with your partner, and some of the groups went to actually a table group, which is fine. It's totally fine. You'll notice that I came by and dropped in and asked some questions. When I was doing that, I was conferring with you as participants, ways that you might confer with your students. So over here on the mathematically productive teaching routines, I structured your talk, just like you would in the classroom where you might structure students' math talk. Okay? And then I was conferring with student mathematicians. So think about it if you're in the classroom. You guys aren't students, but I was conferring with you. And the questions that I was asking were researching questions. Can you tell me a little bit about your model? Can you tell me about the meaning of subtraction that you're thinking about right now? And then in a couple of places, I left you with a question, is there a meaning of subtraction that might fit that model if a student had it in front of them in your classroom? So kind of a question that I dropped and then moved away from. Okay? But again, wasn't necessarily after a specific answer. I really wanted to know how you were thinking about it. Just the same way I would in my classroom. I really want to understand what my students are making sense of so that I can make that next instructional decision. I just wanted to call out that there's a couple of things that we were doing there. back to the structuring talk. So now think about the process where partner A got to share, partner B got to share, and then you had an opportunity to talk together about how your ideas were the same or different. What math idea did your partner strengthen for you? Think about that for a minute. And just turn and tell your partner something that they helped you think about in a different way or help strengthen your thinking about it. All right, and again, that was just a real quick check-in. Would someone be willing to share something that their partner strengthened for?
Well, Steve brought up the idea of zero pairs to try to do the a different way of showing 8 minus 3.
Okay.
So
that might be something that didn't come to mind immediately when you started thinking about it. So talking with a partner brings out an idea that might not have been on the forefront of your mind. Fantastic. And then along that same line, did anybody think about something different because their partner shared? Similar questions. Anybody's thinking change or think about it differently? And again, questions that you might ask in your classroom, or you might tweak these a little bit, but thinking about helping students see the benefit in structuring talk. So if they know why you're after this and how it's going to help them and their understanding, it can be really helpful in getting them to kind of go along with what you're trying to put into place. So then let's go to that bottom one. What are the benefits of structuring student talk in the classroom?
I use the turn and talk a lot. And what I like about this one is the listen and compare. It's a little bit more specific, and you've got more of a structured time of the first person talking for a certain amount of time. Okay, now switch it, so it's a little bit more control of trying to get people to talk as opposed to turn and talk. It's just kind of one person's real good verbalizing, the other person isn't. So I like that.
Yep, absolutely. So it does make sure that everybody is held accountable to sharing.
Yeah.
It makes sure that everybody has, at least initially, some equitable time to share, because sometimes you get partners where one is really very talkative and the other one's fairly quiet and would be willing to sit back. If you turn to page 58 and 59 in your notebook, there are a couple pages there that talk about structuring student talk. So page 58 is the actual protocol that you might follow along with. So can I get someone to read the 2 bullets at the top under purpose? Thanks, Doug.
Purpose is support the development of student-to-student interaction that is consistently equitable, status-free, and mathematically productive. For these purposes, mathematically productive means that student interactions consistently include students' mathematical reasoning, sense-making, representations, justifications, and generalizations. Provide formative assessment information that drives instruction and decisions.
Fantastic. So the first bullet I want us to think about here for just a moment. As we're thinking about conversations in the classroom,
Yeah, this is
And all my technical.
Welcome to
hey, thoughts? That looks like that's
the projector
on.
go?
I think that means break time.
Break time.
yeah.
Yeah, right?
So I'm gonna leave it alone for just a second. We're gonna, that's gonna give everybody a headache.
It could be.
I can go with it. Yes.
It's on her computer.
Try to make some of my students feel like they're in class.
You know, whatever is going on in the city. You know,
There you go.
Okay, I don't know if it's, actually I've not had that happen before. But I want us to think a little bit about whether that student interaction in the classroom is status-free, equitable, and mathematically productive. So by using a structure for structuring student math talk, we can get at that equitable piece because we're making sure that everybody has an opportunity to share, that all voices are heard, that all ideas are important. It might not be that every idea that comes out is what you want to bring forward for the whole class to make sense of, but it's really important that those ideas get out there. And the status-free part, so I'm going to go back to Dan, right? Matt, I'm sorry, Matt. So something that Matt said about having a pair where one of them is really talkative and one of them isn't, it will be easy for the talkative person to kind of take over. Or think about some of your classes where you have a student that has a lot of status and maybe somebody who doesn't have as much status. If they're partners, it would be really easy for the student who has a lot of status to either take over or be deferred to. So trying to get at some status-free interaction as well, that everybody's ideas is heard. And then the last piece is that mathematically productive. That not only is the protocol piece of that, but what you ask kids to talk about is really important. So having kids make sense of, in this case, you guys were thinking really hard about a model and the meaning of subtraction that went with it and how they went together. But thinking about what we have students talk about in that structuring of student talk is really important. It can't be, what's the answer to question number 4? So then when they look at each other and say, well, it's 3. Okay, then what? So thinking hard, what's that question that you put out, that prompt that you use to make sure that they're having an opportunity to think in a really important way about the mathematics. So I want us to think together a little bit about, go there. I want us to think about some of those meanings of subtraction. So, to start with, I stopped over at this table, and Matt, you were talking about, no, Dan was talking about one of the meanings, right? Okay.
Here's Dan.
I've got Dan. Okay. I have your name on my brain now, and I'm going to call everybody that.
I'd be honored to be called Dan.
I don't know. That might be a status equity thing. I don't know about this. Dan's the most popular. Wow. What's going on here?
So it's not an intentional teacher move. It was. It's me showing a place where I really need to work on things because faces. And we meet each other at Safeway after this, and I'm going to remember that I know you
because everybody has beards.
But I have to work really hard on names. Right. So Jason and Matt. Okay. Okay. And so please at lunchtime don't switch those up on me.
Dan's the only one with personality.
All right, I'm going to draw us back up here. So I want us to think really hard about a couple of meanings of subtraction here. And when I stopped in and talked to Jason and to Matt, they had one meaning that I had asked them to share about. And you guys had, Matt, do you want to talk about it? Or Jason, you want to talk about it?
Sure.
And would it be helpful to put it underneath the document camera?
Sure.
I love it when they say sure. So again, I want you to think about what could have just gone wrong for me in the way that I asked that question.
It says no.
Yes.
Nope.
Yeah.
Do it.
So what was my question just there?
Do you want to?
Do you want to, or would you be willing to?
Switch from the laptop.
Yeah. There's the program on the computer making it go to.
Okay, so you can't do it just from the.
I don't think so. I think you got to have a hover.
It's just the input on the.
Yeah, switch it from here.
Okay, yeah, because I just unplugged that and plugged it in here. I didn't undo anything else. Okay, that'd be awesome.
All right.
Thank you.
Oh, this is awesome.
You want?
3 greens and the 5 reds. So I've got a total of 8 chips, and the reds reds are the ones that I'm taking away. Subtraction can give me the 3 greens.
Okay, so you had.
So I have a total of 8 items.
You had a total of 8 items.
8 items, 3 green, 5 red. And the red is the subtraction, taking away, leaving me the 3 greens.
Okay, so I'm gonna try to capture what you said. So I have
8 items.
8 items. 5 green, 3 red. I take away the 5 and have 3 left. Is that correct?
Correct.
Okay. So I'm going to ask you guys to think for just a moment. Thank you very much. So again, capturing what Matt is saying as closely as I can here on the public record. I want you to think for just a moment, what is an everyday life situation that would fit this meaning of subtraction? So just real quickly, 30 seconds, turn and tell your partner, what's an everyday life that might fit that?
It could be.
5 get out.
8 apples.
Gallons of gas.
All right, I'm going to pull this back together.
I think about the unhealthy.
So I'm chuckling because the same thing happens here that happens in the classroom. Almost all of those ideas were food. So Matt talked about apples. I heard cookies coming up over here.
Not much he does talk about food.
So Matt, give me your, you said I have 8 apples.
8 apples, 5 green, 3 red.
Okay.
I threw 5 green ones at Jason.
What, did you throw 3 at him or did you throw?
I threw 5 at Jason.
Okay.
So
I
missed him
threw
3 times.
5 apples at Jason. Okay, and what's the rest of it?
And I have 3 more to throw.
Okay. Or, and let's phrase this as a question. What question would you be able to ask at that point?
How many apples do I have left?
How many left? Okay. So what is the meaning of subtraction here?
Figure out how many are remaining.
Yeah, we're looking for the leftovers. So we're going to call it takeaway. Because I had 8, and I took away, in this case, 5, and I had 3 that were left. And that was very, very similar to what I saw around the room. So there's a second meaning that I want us to think about here. I'm going to pull this down. Put that over there. And there's a number of people who had something real similar to this, but we're using positive and negative numbers. So, and again, I'm just going to say that transparently because I think every group was talking about this. So if I had, this is what I saw in most of the groups. If I had 2, 3, 4, 5, 6, 7. Okay, sorry, they're a little out of proportion. And then I had 5 like that. Okay? And so you guys help me think about this a little bit. So what was happening here in your group? So I'm going to come back over here because I had asked Dan, and Steve, and Seth. I had dropped in and talked to them a little bit and asked them to talk to me about this model that they had laid there. And I asked the other 2 groups the same thing. But what did you guys say to me?
Said basically that if you have 8 total and then you have 5 that are zeroing out, so you have the positive and then you have a negative, and it basically makes them zeroed out.
Yep. So it could be that these are 5 positive, because our problem was 8 subtract 5 equals 3. It could be that these were 8 positive, these were 5 negatives, and that they zeroed out and left us with 3 there. Okay? question I asked, and I asked this at the other two tables, is there a meaning of subtraction that could be represented with this model where all of these were positive? And I came back and checked it with you guys. Did you guys have another thought on that? So I just want to, so in the Common Core, they would think about this as comparing, which is essentially what you guys were doing in terms of matching these up to think about how much was left over. But given that we were working with positive whole numbers, thinking about how could this represent subtraction rather than adding a negative, which we know mathematically is the same thing, and you're calling out that really important connection between addition and subtraction. But coming back to, so what is that meaning of subtraction that we would want students to make sense of if they were working with, you know, either all negatives or all positives? In this case, we've got all positive numbers. So let's think about how would we verbally say that? Or what would we want students to say? Yeah.
8 is 3 more than 5.
Okay, so 8 is 3 more than 5. So what's a context that we could, what's an everyday life situation? I'm going to have you just turn and check with your partner. What's a situation where you might be comparing to find that difference?
Thanks. Oh, it's not all of it.
So how old is that? All right, if I can pull us back together.
Like a real life application.
All right, so Rebecca has an example for us. Rebecca, would you share your everyday life?
Sure, it just so happens I have an 8-year-old son and a 5-year-old son. It just so happens. And I have a 3-year-old son, go figure, right? All three of these numbers. Anyway, so Elliot is, well, Evan's the one that's 8, but.
Okay, okay.
Yeah. So Evan is 3 years older than Elliot.
Okay, so that's what we're trying to trying to figure out. So if Evan is 8, and you said Elliot is 5, is it E-L-L-I?
Yeah, 82 L.
Okay, Elliot is 5.
Yeah. So we would say.
So what's our question then?
Don't bring us down.
Hopefully I got the students, hopefully I got your children in the right order.
Yeah.
But thinking about that comparing or that difference.
You could add on here, and Luke is the difference. And you really have a cognitively demanding.
There we go. But I want us to think about how these two ideas, I mean, they get us to the same spot, right? They're both subtraction, but they have a little different flavor to what they're bringing out about the subtraction. And again, we're just dealing with whole numbers right now. We have not moved into the situation where you might have integers, you might be working with rational numbers, etc. But we're going to continue to think about these meanings of operations and how they hold true over those different numbers that we might be working with.
So would you specifically teach difference to mean comparing versus takeaway?
I don't know. It's a good question. What would you do? If these were what you wanted kids to make sense of, what might you do?
For my students, if they just get one of them right, I'm really happy.
Yeah, and we do want success for students. So anybody else want to chime in? Repeat your question if you would.
I did. She listed difference as being a synonym or related to comparing, and I just asked then, is difference not mean takeaway? That you would not use it in that context?
What do you guys think?
Well, I was saying that this would be a good poster to have up for students that I'm familiar with, because I always had a keyword poster, and this is the one that they always had the most trouble with. I like the little picture, you know, on the visual, versus having the poster that says how much older, / more, / faster, / less.
Because you can then press, you know, for where do they see these numbers in the picture? Where do they see these numbers in the story? So I could ask, I mean, so again, if you guys were in my class, I might say to you, so where do you see the 8 in the picture? Want to just tell me real quick?
Okay.
Yeah. So then you could help them see this is 8, and this is 5, and that was the 3. So back to the question, one of the things that goes through my mind is that subtraction problems you might solve with subtraction, don't always lend themselves to being said one way. So I think about, I want my students to be able to work with any problem that's out in front of them. Sometimes they'll see things like this, how many are left, how many are remaining. But sometimes they'll have a question that's written this way. Do you ever have students in your class say, what am I supposed to do? Should I add here? You want me to multiply here? I mean, I know in my class that happens a lot.
Just add everything, they see numbers and just add them all.
Right, or they start to do something with the numbers.
Yeah.
We want them to make sense of what they should be doing with it. And part of that can be making sense of the different ways of thinking about an operation. Even if they're not calling it, this is my compare method, or this is a difference method. If they know that there's kind of different flavors of questions that might be out there, and how to make sense of what they should do with it to solve the problem, I think that might be the goal. If it's helpful to name them, you know, great. I mean, there's nothing wrong with doing that. But if they don't necessarily call it by a certain name, but they have that understanding, it would be really helpful. Other questions? Okay, and again, just to be real quickly, to be transparent with you, this was called out, you know, in the opening. I did not just randomly choose people to come up and share. I was thinking really hard about working with selected and sequenced ideas. Okay? So it wasn't a volunteer per se, it wasn't a random. I knew I was going to come over here and start with Matt and with Jason, and I had found out what they were thinking about by conferring with them. I had conferred with other people as well, and then selected them to get us started. I also knew, because I had talked to each of the groups, that there was this idea about putting the positive and negative numbers together that had flavors of that comparison, but not exactly what I was hoping would come out in terms of the meaning of subtraction. Wanted to make sure that we brought this out and connected it to the thinking that you were doing, because that's really important thinking. So I'm going to slide this over here so that we've got our 2. And buried my, let's see if I can do this without sending it. I want to make sure I don't set it off again. So on page 19 in your book, and a lot of people are already there, which is great. There are some 4-part charts that you might use as we're thinking about these two as well as some others. So 19 and 20, if you want to make yourself some notes from here or about your own thinking, that's totally fine, just to kind of think about what are those meanings of subtraction. The other thing I want us to think about for just a couple minutes here is when you were in the structured student talk, when you were working with your partner, and just now as we were, you know, working together, whole group, what were you doing when you were listening to understand? Again, I'm thinking about, let's be really explicit with each other. What did it look like and sound like when you were listening to understand? And how might you take these ideas back and think with your students about what it meant to listen and understand? I'm going to have you check in with your partner. Think about, with your partner, at least one example of what it looked like when you were listening to understand, and one example of what it sounded like when you were listening to understand. I'll have you try and chat with your partner.
Yes.
Each person gets a chance to talk.
I'm just not about it. But like if I'm looking to understand
One person talk, one song.
Oh, they're.
but not out loud, but you'd see the person. versus just-
All right, let's come back together real quick. So let's just capture a few of those ideas out here. I'm gonna start over here at this table here with Seth and Steve and Dan. What's one idea that you can put up here? What were you either, what did it look like or what did it sound like when you were listening and understanding?
Looking at your partner, eye contact. Gazing lovingly into your eyes.
Awkward.
Well, we might do that here, but you wanna think about whether you set that up for your students. Okay, let's come over here, middle table. What's one thing that it looked like or sounded like?
Smiling and nodding so that it felt validated.
So smiling.
There's no smiling.
No smiling.
A lot of love in that
Hey, oh, hang on a second, I'll make sure you guys all hear the ideas coming out.
Not doing anything that would distract you, so
Okay.
not writing anything, not fidgeting, making sure your full attention is on the speaker.
No distracting behavior.
And it sounds like silence,
Okay.
Sound of silence.
right?
Okay, so silence by the listener.
Right. Hopefully.
Yep. Yeah, hopefully the person who's sharing that you're listening to isn't also silent the entire time. Yep. How about over this table?
Well, it's looking at partner, but then also looking at their visual
Okay.
as they're describing it, so that you can kind of process what they're talking about.
Looking at visual. Could we, and I saw some people pointing.
Yeah, we talked about how if you're giving the listener a purpose for listening, then what it would look like was them actively pursuing that. So like if Jason and I were talking and my purpose as a listener was comparing, you would actually physically see the eyes going between the two models, or looking at their paper, then looking at yours, like if you're comparing. So, and I would disagree that looking at Jason the whole time would be listening to understand. Because if I'm just looking at him, then I'm not actively doing the task of comparing or contrasting.
So it might be some combination of these then.
Right.
I might be looking at him to make sure that I understand what he's saying, and then looking down to what's happening, his model, my model, back to, yep. Yep. Anything else for what it might sound like? So if you're the teacher in the classroom and your kids are engaged in that piece, we know the listener is silent. What might that back and forth, maybe I just said it.
Questions?
Okay, so it could be that there's questions, and this might be written. So if I'm really listening, I might jot a question, and I realize we're talking about not distracting behavior, but if it's your turn to talk and I have a question I don't want to lose, I might jot that question down real quick.
Positive feedback.
Okay.
Affirmations of. Yeah.
But when you're writing the question, now you've disengaged from what they're saying.
Well, it depends on how lengthy your question is. I agree, because if I stop listening to think about a long question I want to write, but if I'm, want to keep track of something that I don't want to forget to ask about, it might be worth taking a couple of seconds.
I know, but as soon as you've done that, you disengage from what they're saying.
Okay, so then thinking about that in the classroom with kids, what do you want them to be doing here? If you don't want them to do this.
So I guess what I'm saying is you've got to teach the speaker to, when that person starts writing, they need to then stop talking so that they can do their thing and then continue.
Yeah.
And again, hopefully we're talking a couple of seconds here, not long pieces.
I think where I can relate this to is what I struggle with note taking. As I'm going down notes, and I always feel like I'm pressed for time, so I got to figure that piece out too. But it's like I get the notes going and I'm just cruising, and I got kids that are just. I can recall when I was a student, being in a freshman lecture class, and geez, I'm not taking anything down, just scribbling down paper. And so I feel like I kind of relate to it.
So it could be as a teacher that you're pausing
Yeah.
periodically, and it could be the same thing that I just pause or I write my question when my partner has paused. Yep. But again, how could doing something like this with your students be helpful?
Sets a standard.
Sets a standard.
mean, you're also teaching them a skill on how to listen and also how to talk.
It's like their success criteria for the protocol.
Yep.
And you're part of the decision-making about what it is, because if you're just standing up and just saying, this is what you should be doing right now, this, you're not, it doesn't make any sense.
Yep.
Yeah.
So students might have the same idea in their mind as you do when you say, I want you to listen to understand. I also think about the difference between listening, which might just mean I'm going to stop talking, versus listening to understand something. And helping the kids really think about what is it that I'm doing while I'm listening, so that I have something that is going through my mind, that I'm comparing that idea or I'm making sense of what that person said. Because we can get kids who are compliant and that they'll just stop talking, versus the student who truly listens to understand what their partner is saying, which could include having a question because they're not totally understanding and they need something clarified. Yeah. But I would think, I guess this is just one idea of what you might do as you're helping kids think about what does it mean to engage in the mathematics in these ways and with each other in these ways. So it could be that as you're working through the habits of mind and habits of interaction with your students and helping them make sense of what it might look like, that you might stop and do something like this or some other strategy that you have. This does not have to be the one, it's just an idea of how to help kids make sure that they really know what this should look like in the classroom. And we're going to keep coming back to this. We're going to spend time together thinking about what are those habits that we're engaging in, what are the really important habits that we want kids to engage in all the time, and what are other strategies that we might come up with along the way.
Now, is there different, like, based upon the grade level, different expectations? Because I know moving from 6th grade the last couple of years to now 8th grade, I'm like, wow, like, the deeper level of conversations that's going on. Because I know the 6th graders is like trying to pull teeth to try to get them to like explain sometimes, whereas 8th graders, they tend to.
So
like when you're, so what grade were you most?
So most of my classroom experience is at the middle school, 6th, 7th, 8th grade. I've also taught at the high school and done some coaching at all 3 grade bands, elementary, middle school, high school.
So did you see a difference between?
So it's actually, so yes, I mean, how you teach the kids to do this might be a little bit different. These posters as visual reminders, again, the posters aren't the end all be all. They are a visual reminder of what we want to have happening in the classroom. And I have been in kindergarten classrooms where these are up and calculus classrooms where these are up and being used in really authentic, meaningful ways. You're right, the actual language that kids use might be slightly different, but it is just one of the neatest things I've ever been a part of to see kindergartners asking each other some of the same questions that we were just asking. So why does that work? How do you know you're right? I mean, they can do that same press that we would ask for in our middle school and high school classrooms.
So then giving them, like, here's the questions we're going to be asking in this classroom?
Absolutely. So that's part of helping the kids think about what they talk to each other about is to, you could either give them the questions, you might give them sentence starters to get them going. You might have them really pay attention to the questions that you're asking because you want to hear those questions coming from them as well. But absolutely, having conversations is helping the students not only learn how to talk to each other in terms of let's be equitable, status-free, mathematically productive, but what questions they might ask each other.
Okay, so setting those up at the beginning of the year, what questions. Okay.
And one of the things that I look for in my own classroom is when students start to use questions that are similar to what I ask. So that's, I mean, not that that's the end-all be-all either, but that's one indication that they're starting to kind of follow along and to make sense of the type of mathematical conversations that you're wanting them to have. Yeah, it's a great question. So just real quickly, I was standing back by the habits back there. If you want to just glance back there, the habits of mind are the ones that have the orange backing on them. The habits of interaction are those that have a green backing on them. Okay? And if you would just call out a few that we think we've been using.
Justify why.
Okay, tell me a little bit about justify why.
We're just explaining the process of what behind what we're trying to explain.
Yep. Yep. So justify why. What's another one that we've been using?
make sure I didn't steal somebody else's. Okay?
You asked us to give an everyday life example, so we have connections to real life.
Yep, making some connections.
Representations.
Representations. So what representations have we been working with?
Tiles.
Yep, we've been working with some tiles, we had some drawings, we had the everyday life, we had the number sentences, the equations.
Explain.
I heard somebody say explain. Yep. So I asked you to explain not only in your partnership, but also in the compare part.
Metacognition reflection.
Say a little bit about that.
Well, with our partner sharing and explaining our process, and then them listening, and then giving us the feedback, and then flipping roles.
Absolutely. So thinking about our thinking,
Mm-hmm.
reflecting on how we're making sense of this. Yep. Any others?
Private reasoning type?
Yeah. Specifically asked you guys to take a little bit of that, gave some rationale. And again, part of that was not only to help introduce you to these things, but also to think about what do you say to students in the classroom? Because they're going to need support in taking these on as well. Any others?
You encourage multiple pathways.
Yep.
We compared our logic and ideas.
Yep.
Our group work.
Yep.
Listen, understand. You just talked about that.
Yep. Yeah, in some depth.
Persevere and seek more.
Okay, say a little bit about that.
Well, it's like that second one you talked about over there, the comparing difference, because we had the positives and negatives, and then you said, so you asked us to seek more, is there a way that you could do that explanation of all positives?
Absolutely. So that was on my mind, because I knew that the conversation you guys were all having was really close to what I wanted us to think about in terms of how the Common Core pulls it out. Yep. Yeah. So again, having kids talk about these in your classroom could be another way to introduce them to these. You could, if you like this, do exactly what I did. Just ask for them to call out which habits they've been using, and then press for a little evidence around the ones that you really want them to make sense of, and or that you know are really important. So again, when we talked about justify right away, tell me a little bit more about that. These top 3 up here are really the goal. We want kids to be making sense of the math, justifying the math, and then generalizing that math so they can use it in a new situation or in other parts of mathematics. And the way we're going to get kids to do that is to have them engage in mathematics through these other habits of mind and with each other through these habits of interaction. So although all are really important in building the culture in the classroom, I would encourage you to keep thinking about how do you use the habits of interaction, this row of the habits of mind, to get kids to do this. And the outcome then is the standards for mathematical practice. These are the tools to get kids to do these things. And if you like the idea of the sticky notes, you could certainly do that. You could call out when kids are doing these things, so you could say, oh gosh, that was a great justification, Ian. Did everybody hear that? Let's think about that together. So you just named what happened. Or you can ask your students for evidence that they did these things. Or you might mix it up and do a little of both. Yes?
Are those in here?
They are not in there, but I would be happy to get them to you. I have them as a PDF file. Be happy to send them. So now, Terry, could I send them to you?
Yes.
Okay. So I'll send them tonight when I get home. I'll send them so that they're here before tomorrow morning. That would be something you guys might think about. I don't know what the district might be willing to do in terms of.
We can print those.
Okay. So they're a color copy that I can send to you. It's just the white part. This is nothing fancy. This is just construction paper that I laminated. So I'll let you guys work with Terry a little bit to see whether it would just be the white copies or whether.
Terry, would you guys like color copies of those for tomorrow? I mean, does that help? Or?
Yes, that'd be great.
Okay, we can do that.
Fantastic.
Yeah, we can do that tomorrow if you send more.
Yep.
Construction paper, laminated.
Yeah. Now we're getting
You put them in my classroom like that?
I'm just asking while we're, you never know.
If you don't ask, you won't receive.
Right.
Yeah.
So just if you decide to mount them and laminate them, just a couple ideas. I mean, you do it however you want because these are for you in your classroom with your students. I went with the colors I did just because of the outline in it. So the color is only because I thought it looked good, not because it had meaning. I have been in school districts where they have opted to mount these on like the 2 school colors. So whatever your school colors are at your school, to mount them on those colors so that they're kind of part of what's happening in that school. I've also been in classrooms where these are on one color, habits of interaction. The habits of mind are on another color, and these 3, the ones that we're really after, are on yet a 3rd color to make them stand out. So just a few ideas, but whatever works for you guys. And again, if Terry's willing to help out that way, that's fantastic. And again, it's not so much about hanging the posters up. I mean, all by themselves, they're just pictures on the wall. But thinking about how do we help kids interact with them and use them as visual reminders of what we want to have happening in our classroom, in their interactions with each other, and how they're engaging in that. Guys want to move around? A little break? Yep. Let's see. It is just fantastic. So thank you for sharing not only your thoughts about the meanings of subtraction, but also thinking with me about the habits of mind and habits of interaction and how we might use those with students. I want us to jump back into the math again together. So I'm going to ask you to think a little bit on your own. So again, we're going to start with some private reasoning time. So this would be quiet time for you to think about this on your own. If you would like to use page 21 to jot your ideas down on, that's fantastic. But I'm going to ask you to think about the problem 12 divided by 4 equals 3. And I am going to press that I want you to use the tiles to be able to show visually how you're thinking about that problem. Once you have something in tiles that you could show, if you want to also write it on your piece of paper in the visual area, that's totally fine, especially if you're going to use your tiles to come up with another meaning. And I'm going to ask you to start with the tiles first, in your private reasoning time, knowing that you're going to get a chance to share with your partner in just a couple of minutes. All right, so I'm going to jump in here real quick. Okay? So I want you guys to think for just a minute. You're in your own classroom, and you still hear voices going after you've asked for private reason time. What might your move be?
Take away their pom-poms.
Okay, so take away their pom-poms. Okay.
Referral.
Okay. No, I'm not looking to refer people. I'm not necessarily looking for those consequences. What might you say to help your students recognize why this is really important?
I'd wait a second just to see if it stopped real
Okay,
quick, like
absolutely.
ours just did.
Okay.
And then I wouldn't actually bring the attention to the classes. Then I would lose their focus for a second. Because there's kids that weren't talking,
Right.
so I just wait to see.
Okay, so, and again, you're going to make those choices in the moment. Okay, so you might wait a second, see if it dissipates. And if it doesn't,
Might
then what?
just take a quick circulation around, or if one group's more chatty than the other, just go stand next to them.
Okay,
Is that
so a little
presence?
proximity.
Yeah.
Yep, okay. What are some other options?
You can draw their attention back to the agreed upon
Yeah.
protocol.
Okay, okay,
So
so,
I think
yep, so coming back to some agreed upon protocols.
Poster that lays out what part of the
Might be, if you've done a looks like, sounds like, maybe bring it back to that. Yep, absolutely. So again, being really intentional about those pieces. Not that there's a right or a wrong move at this point, but just being really intentional about what you might choose to do.
And I think being consistent.
Ah,
If you
yeah.
set the tone from the beginning, and then they know what the expectation is.
Yep.
Because they'll always try to push the line to see what they can get away with, but they know what the expectation is, typically that problem goes away.
Consistency in everything we do is really important. Okay.
Laura, one of the questions you asked, and I didn't hear a response to it, which was, what might you say to reinforce why it needs to be private think time?
Okay. So what's your rationale?
Because you're really trying to build a culture for the kids. It's not trying to just manage their behavior.
Correct.
And if kids see purposefulness in not visiting with their neighbor, then they're more likely to adhere to it.
Okay. So what's your one-liner about?
Sometimes I think the groups that are doing what I'm looking for.
Okay.
Thanks, table one.
You're honoring everybody's opportunity to think on their own before we start to share. Yeah, nice. So again, if you hear ideas coming out anywhere through the day, please grab that important moments and jot those down. But I am going to stop talking and honor the private reasoning time and give you a chance to think about 12 divided by 4 equals 3. Ask you to share with your partners how you're getting started on this. What meaning of division you're currently thinking about, how your model represents that, and if you've started to think about a second meeting. I'm actually going to use a go-around this time, given that we've got 2 groups of 3 and a group of 4. So I'm going to ask the person who's sitting in Jason's spot to start. Okay. But I'm going to do a structured or a timed go-around this time. So I'm going to give each person about 45 seconds. And again, think about your own classroom. You may or may not say that exact amount. I'm being transparent right here. I'm going to give each person about 45 seconds to share, which isn't a ton of time. And so Jason will have a chance to share, that's the person, or the person sitting in his spot or closest to it. Okay? And then we'll just move around the table. Each person gets to share. What I want you to be thinking about is how are your ideas the same or different from what the person before you or the people before you have shared. Okay? Please be listening to understand when it is not your opportunity to share. Thinking about some of the pieces we just talked about, when it means to listen to understand. I'll call time when it's time to move on to the next person. When we get through the 3rd person, I'll let the 2 groups of 3 just start into a conversation about how your ideas are the same or different, and we'll make sure that the 4th person in this group gets an opportunity to share. Okay? All right, person in Jason's position may begin.
I have 12 group, then divided into 4.
All right. Partner 3, finish your thought. So the 2 groups of trios, go ahead and slide into a conversation about how your ideas are the same or different. And I'm going to give partner 4 an opportunity to share.
But anyway, my visual representation is like 4 times 3 separate groups. So I have 12 total files. Well, obviously, in each set there's 4 separate files. And then how many total?
Modeling?
Groups of 4 or 4 groups of 4.
I guess you're as soon as you're done with this, you can slide into a conversation.
What's to do with those things? Same or different? What we yeah, exactly. Wait. Well, really, I mean, I've got 3 separate groups.
You keep your mind on the inverse of
So I think I heard you say that you were thinking about these in 2 different ways.
No, actually,
Right.
But
Okay.
you made me think about it.
Okay.
Because.
Steve,
Yes.
okay, start Steve.
times.
I'm learning
No
names.
problem.
I'm working on hard on it. Okay, so I wanted to start putting names.
Yeah,
Tell me
yeah.
about how your 2 different ways that you were thinking.
That way,
Looking at the number of groups, so that if I do this, there's 4 groups. And then there's 3 in each group. Another way to do it is divide it up into groups of 4. And the number of each group. And then you end up with 3.
So what are you thinking about with your essays?
It makes sense, but this is the, I mean, this is the way I did it, but also the other way makes sense to me.
And Dan, how are you thinking about it?
It's the same as the way it's modeled based on the questions being asked.
Okay. Is there any other way that you guys could think about
So that's how to think about it.
Yeah, so we're thinking.
Perfect.
Right.
See, you're
I'm a
asking the
facilitator.
I can go home.
Oh,
You
yeah,
don't have to
exactly.
ask the question.
If it's
So what's,
You can think of it as like the fat family, you know.
Oh, there you go.
what about
Four,
beyond,
four.
so are there any other meanings of division that might show up? That's not about the representation.
So, well, I just started with 12 total tiles.
No good.
And then after obviously collaborating and stuff, there's a representation.
Tell me what an idiot you are.
It seems like it would probably.
No.
Created 3 subgroups, so I've divided the 12 into like 3 groups instead of 4, so adding another, or creating a set of 3 and then adding another group, maybe with different colors.
So I think it could be important for us to think about what we did here and how it's the same or different than what the partners did. So
Ian, tell me a little bit about your representation.
12 divided by 4.
Just have to grab your sandwich and you grab my bag.
Okay.
Just walk. Walk around.
So you're really
Walk and eat
asking,
at the same time.
what's the question you're asking?
She's not an associate dentist. She's a center.
And you're looking to find out how they're in a group.
No, but she
So how is that the same or different than what college?
It's all over. Most steps are a little bit.
Sort of looks similar.
Is there another way to think about it? I know they're
We have different ones.
so they don't all calculate.
Did you guys write a word problem?
That's 4, but
So I'm gonna leave you with a question that is not so.
But not every
Ian,
school
you
is
said that
selected.
you're looking at how many different groups.
That's only, it's only
So,
between
what-
eight,
so what about,
eight,
so
yeah.
thinking about what is the question that comes
Because I
up?
wanted to
Let's
see.
say
Depends on the student.
Right, exactly.
I think there's like 14.
Tell me about this model.
Yeah. Similar to my thinking here, so I went, okay, I have 4 people that are doing sharing all these blocks, so then I just sorted them into an array, into
3 times 4 is 12.
3 times 4 is 12, and it's similar to his.
I'm just trying to stick by my presentation. Argue it out. What's wrong with me? No.
This
is meant to
And how is that the same or different than your idea?
I said I started with 12 and I put them into groups
You
of
were able
4,
to
so I ended up with 3 groups. And she's talking about she did 4 times 3.
Is there any other meaning of division that you're thinking about now? Or that you might then seek more and think about? Look for?
So it was, one was groupings. And the second one.
So you've got 2 different models here, I mean, that are very similar, but have
Oh,
yeah.
different connotations. to them.
Right.
So thinking about the 4 groups of 3 versus the 3
I
groups
mean,
of
they are
4.
2
I'm
different.
gonna just leave the
Right.
question,
Methods of division.
but is there another meaning of multiplication or division out there? that you
Yes.
might want us-
Ballpark, let's divide it into 4 teams.
And maybe it's beyond anything.
Let's divide it into teams of 4.
Right, yeah.
What do you guys think?
We came up with a
So how are
try to
you?
go through it
Nice,
that way.
okay,
Well,
great.
you came up with another way to explain besides those 2 other ways, or besides. We went to the multiplication, I mean, we did it through operation.
Yeah, well, and then because they're so tightly tied together, that, you know,
Yeah.
oftentimes when we're thinking about division, we can
Right,
do it
yeah.
at the same time. But you came up with some everyday problems and like go with each of these? Nice.
Yeah, I guess, I could just manipulate numbers to make it work.
Yeah.
Yeah, exactly.
So is there another way?
Am I leaving you with the challenge or frustrating you?
No, because you said right up.
Yeah.
As far as what, modeling?
Yeah, yeah, so things beyond groupings. So how, where else might you see multiplication or division? What kinds of problems might you see? And we're gonna talk about that, I'm not, I'm just kind of leaving the question. We're gonna come back together in just a couple of minutes, and I'm wondering if, without rephrasing the question, so I would really appreciate it if you and Al, if you guys would share the 2 models you've come up with, and then you guys would be able to share the conversation you're having. What's his name? Sure. Preference on who goes first?
Reorganized multiplication. Buckbeat?
All right.
Wanna go first?
You're gonna be it. Okay. All right. So I'm gonna bring us back together.
You don't have to put your.
I don't have to put my hand up. Well, that is ingrained in me because in my classroom, this is my signal, so that students know that they should finish the sentence they're on and then come back to me. So again, I appreciate you telling me I don't have to, but I don't know if I can stop myself. Too many years of being with students to not always let go of those pieces. We're going to do a little bit of debriefing here around these different meanings of division. And I've asked Ian if he would get us started. And again, I stopped here. I'm just going to be really transparent. And I started out saying, would you mind? And then I stopped myself and said, I would appreciate it if you would, in terms of asking them to share. Because there might be students in your classroom that you could ask to do that, and they're going to say yes because I know that's your expectation. But thinking really hard about the words that we use and making sure that we're setting them up for success, but not necessarily a way to opt out. I was also stopping in to let them know that I was going to ask them to come up and share. So again, in your own classroom, you might think about what kind of heads up might you want to give to the students that you want to have come up and share. And if an individual student has more than one way, making it clear to them which strategy you want them to share at a specific time. So just a couple of things that you might think about as you're encouraging students to come up. Once again, I'm going to capture some of the conversation on a public record as we do this so that we've got it to refer to, especially once we get a couple different meetings up there. So, Ian, would you be willing? Let me rephrase that. You guys have to stay on top of me. Ian, please come up and share your thinking.
Can I just draw it up there since I can't really juggle?
Sure, or if you want to talk about it, I'd be happy to capture it for you. So what have you got?
So there's 9, it's kind of hard. There's 3 squares.
Yep.
Boom, like that.
Yep.
And then it goes down 4.
So you've got this.
And then I kind of would like to highlight one of those rows and circle it. So the answer is 3. So like, yeah, there you go.
Okay. So there's 3. Okay. And you were talking about 12 divided by 4 equals 3. Okay.
Yeah.
So talk to me, just kind of tell me how you, and this particular model showed up in various places around the room. So Ian, talk about how you created this, and I'm going to capture your verbal. And I want other people that thought about this model to be thinking about whether theirs was the same or different, and whether they had a different way of thinking about it. Okay?
I'm starting with 12 tiles total, and then I'm dividing them into 4 rows. And then each row has 3 tiles in it.
4 rows with 3 tiles in each row. Okay. So I know some people were already thinking about, the everyday life because they knew that this was going to be a question that was asked. So turn and tell your partner real quick. What is an everyday life situation that might match this particular meaning of multiplication? Turn and tell your partner.
That's an important one. With 4 buddies. That's a big deal.
I always used to use this
Like in a TV training where there's 4 groups.
Oh.
Bam.
So say it one more time.
A TD, 4 groups of people at 3 different times.
Okay. All right. So let's come back together. We got a couple of, I heard pizza come out, so I know we're getting close to lunch.
Yeah.
So let's think about this for just a minute. So Ian said that he started with 12 tiles, and he put them into 4 rows, right, of 3 tiles each. So what is he really trying to figure out? What's the question that he's asking? If he had 12 and he said, I've got 4 rows,
How many are in each row?
how many are in each row? Or how many are in each group, right? Okay, so what is an everyday life that would fit that? Matt, did you want to?
Oh, that there is 3 tables, no wait, 4 groups of people at each table.
Okay, so we're in a training and there are 4 tables.
No, 4 people at each table.
3 tables.
Okay, so let's think
3
about it. So we're
tables.
looking for how many are in each group. Okay, so
4.
there's,
4 people at each table.
okay, so how many tables? So how many tables? So are we then looking for how many groups or how many are in each group?
And how many are in each?
No, we know how much is in each group.
How many
Four,
tables?
so we need to know how much is.
Okay, so again, this is pretty subtle, but it can lend itself to different types of questions. So it could be, how many tables are there? I mean, so there's 4 tables, right?
No, 3 tables.
Okay.
There's 3 tables, not 4 tables.
4 people at each
She's
table.
not gonna buy it.
So I'm going to hang on, right? Okay. So here, so I'll be transparent. What's going through my mind is I really want us to compare and contrast these 2 meanings of multiplication. So I'm actually going to hold off for just a second with that everyday life and have us think about another meaning, and then come back and we're going to put these side by side and figure out that table piece. Okay? So Kyle, would you be willing to share?
Sure.
You guys have got to catch me.
Yeah.
Do it, Kyle.
Kyle, please share your thinking.
All right. So I had. Let you get set up there. So I had the same, I guess, starting process. We have 12 total tiles.
Okay, 12 total tiles.
And then I divided them into with 4 yellow, 4 green, and 4 blue.
So divided into groups of 4.
Yep, groups of 4. And then how many groups are there? I think that's a good question. And so my visual representation, I just had 4 blue tiles up top.
Okay, so you had 1, 2, 3, 4.
And then 4, 4. So 3 rows and 4. 3 columns. Yeah. And then
And you're looking at the same problem.
yeah, so those
Okay.
ones there.
So what are we trying to figure out here?
I guess minus how many groups total.
So, when looking at that, then the first one there, shouldn't that be 12 divided by 3 equals 4?
Ah, that's a good question. What do you guys think?
Because that's how many there are in each group. That's not how many groups there are.
So you just hit
So
on
how
the,
you ask the question.
yes, you just hit on the 2 meanings of division. Or 2 of the meanings of division, not the 2 meanings, 2 of them. So we could look at how many groups, and the Common Core, this would be number of groups unknown. Okay. And down here, where we're looking at how many are in each group, we're looking at, so in the Common Core, it's group size. Unknown. So let's come up with everyday. And I'm going to actually have you turn and talk to your partners for a couple minutes. So with your partners at your table group, come up with an example for each of these. So what's an example where you're looking for the size of the group, and where's an example of when you're looking for the number of groups? What's a context that you might use?
Tables and chairs.
It could be tables and chairs, it could be something else. You could use pizza or apples or whatever, whatever you want.
It has this stuff.
How many groups? 12 divided by 4.
12 pencils, I get 4 pencils each of the students. How many students do I get at a time?
So how could that same context be turned around?
So if I give 3 pencils to 4 students.
To each student.
To each student, yeah.
All right, let's come back together for just a second. So what you guys have called out are 2 important meanings of division. I'm going to come over here to the far table group, and Seth, you were writing something down as your group talked about this. What were you guys thinking about in terms of a context?
Just the problem was I have 12 pencils. I give 4 pencils to my students. How many students did I give pencils to?
Okay, and which one of those does that match?
How many in each group?
Okay. How many are in each group, so the group size is unknown? So say that one more time, and I want everybody to think about it. Do you agree?
I'm going to think about myself on this.
Okay, no, then we're thinking about this together.
12 pencils.
Okay, 12 pencils.
I give 4 pencils to each student.
Give 4 pencils to each student.
How many students did I give pencils to?
Okay, so how many students did I give pencils to? So how many groups of 4 pencils do I have?
Yeah, right.
Okay. So the number of groups is unknown at that point. Because I don't know, so I have, let's write that down.
On your sheets.
Ooh. Boy, after you stick them and unstick them a few times. Okay, so let's think about this. I have 12 pencils. And tell me what you said.
I give 4 pencils to each of my students.
4 pencils to
My students.
each student.
How many students did I give pencils to?
How many students did I give pencils to? Okay. So Matt, would you share your observation? No, you were just looking at your resource. You're looking at your book.
Oh, we were talking about commutative or associative property.
Okay.
It has nothing to do with division, but just that, with the multiplication, it
Okay.
doesn't matter what order they're in.
Yeah, so multiplication, you're 100%
It
right.
doesn't matter, division does.
What's that?
Division does.
In division, yeah. But I think that what you're thinking about in terms of looking at the multiplication is really important because division and multiplication are so tightly connected, being inverse operations. Not every rule that we have for multiplication. You can have the commutative property or the associative property of multiplication, but not necessarily.
Well, it's because there are 2 models, there's 3 by 4 and 4 by 3. It's just the opposite of each other. So when we do this question, it's like we're using that property, it's the same idea.
Yep, and we're just digging into, what we're digging into here is a pretty subtle piece, but we want to think about the different kinds of questions that are being asked. So how can we take that same pencil problem, same context, we got 12 pencils, and how would we write that and think about the question that's being asked when the group size is unknown? You wanna?
Well, if you were to do the other version, you would have 12 pencils. You would give the pencils to 4 students
Okay.
equally.
I give or share 4 pencils with, was it 4? No, 3.
No.
3 pencils with each.
Well,
Yeah,
now,
that-
I don't agree. Now you're
That
dividing
question
12
doesn't
by
line up
3.
with your numeric symbols.
Okay. So I have 12 pencils.
I
So-
give pencils to 4 students equally.
Okay, I give 4 pencils.
Nope. I give to 4 students equally. I give my pencils to 4 students equally.
Right, we're not.
Okay, I give my pencils to.
4 students.
I'm trying to match your words.
What are you saying?
Okay, so say it again.
4 students equally.
To 4 students equally.
How many
Okay.
pencils do they get?
How many?
How isn't that the same thing as I give 4 pencils to each student? How's that different?
What do you guys think?
I
Just
could say,
depends on the label
I
to
give
your
4
group.
pencils to each student equally.
So let's think about this. I give 4 pencils to each student. How many students did I give pencils to? So here we're looking at, we don't know how many students got pencils. Right? So the number of groups. So then I have 12 pencils. I give pencils to 4 students. So how many pencils do they each get? So I know how many students are going to get it. So I know how many groups. I just don't know how many they get, so I don't know the group size.
Well, you just swap students from them.
Yeah, right.
Yep.
So they're not the same answer.
Okay? So what do you guys think? So it says we just.
Here there's 3 students, there's 4 students, so it's not the same question.
Okay. So how would we want to change it if we're thinking about group size? So what is the group here?
The group is the students,
Okay.
and the size are how many pencils they're getting,
Okay.
right?
What do you guys think? So over there we didn't know how many students were going to get pencils. Over here we didn't know how many students. How many pencils each student was going to get.
I think Seth made a great example of the 2 different kinds of division.
I'm still struggling with what Matt was saying because these are different problems.
Yeah, they're different problems.
They have different
I don't-
meanings. So
So I don't see
I don't
how
know how we're
related.
comparing
Yeah.
two methods if they're just different problems. Like, how would two different methods look where we're trying to solve the same problem?
Okay, so we're thinking about two different meanings of multiplication here. In one case where we don't know the number of groups, and in one case where we're looking for the size of the group.
But couldn't group also be talking about groups of pencils? And does group have to be people?
So the number of pencils could be the size of the group, and how many groups of pencils or students, because we're giving a group of pencils to a student.
The one on the right is you've got 12 and you group them into 4 and disperse them. Excuse me. And then the one over near you is I have 12. I disperse them to 4.
Oh.
I mean, that's, I'm not rephrasing.
No, this one is, so this should be 3. Sorry, that's my.
That's what I'm saying.
Okay,
Well,
sorry,
so
so,
now you
because that's a
change-
3 students, and then how many
So
pencils are
then
they
you've got to
getting?
change your
Yep.
numerical
Right, then
above,
does it-
because
oh,
now it's
no.
12 divided by 3 equals 4. So
What do
again,
you guys think there?
it's a different problem.
I was saying the one on the right is 12 divided into groups of 4.
Yeah, so
And the
like-
one near you, what as I had said, it was
So-
12
Does this,
dispersed to 4 groups.
Yeah, we could do.
so does this have to be the number of groups?
Well, no,
No.
I'm not saying that.
Okay.
I'm just saying that the way you have that problem in everyday life,
Yep. So
it's 12 divided by 3
okay.
now.
It was
Why-
12 by my four,
was
right?
12
But you
So-
just change it to a 3.
So if I share out the pencils, 3 to a piece, and then the question is how many students got pencils, right?
3 students. That's in.
In its original form.
Okay.
Yeah, 4 pencils.
You can only create
Yeah.
your numerical
Yeah.
expression from your
Yeah.
data.
No,
Your
I'm-
data is
I'm-
12 pencils and 3
Yep.
students.
Mhm.
So what if we did that? I give 3 pencils, I'm trying to put,
I think we should work in table groups and try to create
there you go.
one problem in 2 different ways.
Okay.
And see
Which
what's
is-
possible.
Yes, yes. So let's not let go of the pencil piece.
Okay.
Okay, so turn back to your partners real quick.
Well, you
What will
can't,
we-
if you're gonna use the same numerical expression, you can't unless you change what the meaning of the value of 4 is.
Right.
Let's see who can
So
solve
you
it.
can't, it's not
Go
gonna
lunch
be
early.
the same problem.
So my press there would be that,
We don't want to use 3.
so the press would be that this doesn't have to be the number of groups. It can be
Well, I
the
know,
number.
I get that.
Right.
Okay.
To stay consistent.
My point is that you can't use the same problem to express
No, it was.
what you're.
Or
You
four
can't ask
pencils.
4 questions.
Yeah, you can't ask
Yeah,
the
so
same
that's- I
question.
think we're being asked to write, use pencils and stuff, but write the question that matters.
Yes.
That's what you're saying.
Yes. So think about it for just a minute and let's
You want.
see if we can come up with a solution. Okay. So go back and say what you were saying one more time.
Was the original problem,
Mhm.
12 related
Yep.
to 4 pencils, each of my students.
Think about something.
So what if I-
Yeah, she's saying that
So
there's a
what
subtraction.
we did.
One way to think about it, the other way.
Because that's what we're trying to
Division. One way is how many
Okay.
groups, the
So-
other is how many
So you
groups. And I
initially
get
said you
that.
had
I'm just
12
saying you
pencils,
can't
that
use the
you
same numerical
give
expression
4
in order
pencils
to
to
do
each
this.
How many?
One's gonna be 12 divided by 4, one's gonna be 12 divided by
So you know how big your group is, but you don't know how many groups.
That's all I'm saying.
In each group. That's what we're trying to do. 12 pencils.
Uh-huh.
So you can use her example there.
Or understand, maybe you can, if 4 can be in one situation, pencils in another situation.
The question.
Disperse them
Then
evenly
the same,
amongst
then the same
3
question.
students.
Students determine
how many pencils did each student get?
So the Common Core is saying that.
But yeah, so I get, you can do that if you change the meaning, if you change the meaning of what the number 4 is.
I'll just say right now.
Right, so I kept changing it as we were talking, so I yes, I 100% agree that's a mess up there at this point that we need to
It's a work
straighten
in
out.
progress, it's a beautiful thing.
Yeah,
You
I'm
have to
gonna
change
grab
the
my.
number.
You guys agree with this,
Yeah.
basically.
For the,
So if you have like 12 horses, put into 4 trailers. How many horses are in each? 3. Right? So that's dispersed.
So what do you guys think?
You've got to,
12 horses.
you're gonna keep the
12
same
people.
numerical expression.
Uh-huh.
You
There's
have
4
to
people in
change
each team.
the
How many
definition of what the
teams?
value of 4 means.
Okay, so tell me how you would change, tell me how you would change
I
this.
just
I'm gonna have
not
us think about this together. How would you change it?
But I was trying to.
Well,
Isn't
no,
that
that's,
And then the other one.
I guess my question to you, I'm throwing back to
Yeah,
you
yeah.
is, do you wanna keep the
Do you
same
wanna know why that
numerical
works?
expression, or do you wanna keep the same meaning for what the value of 4 is?
So I wanna work with this.
People in
Okay, so in the first one, 4 represents
So one of them is
pencils.
12
In
people,
the
4
second one,
people in
4
the
represents
teams.
groups.
How many
Okay.
Then we're
teams?
finding the individual
Those
pencils.
are,
Okay.
he's got.
So how would you word that?
People
For
divided
press
into 4
I've got 12
teams
groups
or-
that are
How many
split
each
between
team?
4
Okay,
groups, how many, between 4 groups, how many pencils does each group get? Or
Okay.
4 people.
Okay, so I'm gonna pull us back together because,
That's,
so let's think about this a little bit. So I know that Seth was thinking about this with his group, and he has a thought on this. And I know Matt was thinking about this with his group. Okay, so Matt, talk to us about what you said, and then Seth and your group, think about how this might be the same or different what your group said. And then middle group, let's think about how that might work with what you guys were talking about. Okay, so Matt, go for it.
I just said that if you want to keep the same numerical expression, you have to change the definition of what 4 means. In the first one over there, 4 represents pencils. In the second one, if you want to keep the same numerical expression, 4 is now going to represent the groups, or
Okay,
the
because,
people.
okay, because we now know how many groups, because what we're actually looking for is how many are in a group.
How many pencils are in a group?
Okay, so what's your context for this one?
My context?
Yeah, what would your question be so that
I have
we're
12.
determining
I have 12 pencils. I have 12 pencils. If there are 4 groups, how many pencils does each group get?
okay? So say it one more time. I want everybody
Instead
to
of group, I'll say students.
okay, so
Okay.
listen to what he's saying.
I have 12 pencils,
Okay,
and I have 4 students. How many pencils does each student get?
okay, I see some heads nodding. I'm gonna come over here because I listened in on Seth's conversation with his partner. Seth, how is that the same or different than what?
I think we switched the numbers around, didn't we? I have 12 pencils, I give 3 students the same amount of pencils, how many pencils?
Yeah, but yours doesn't reflect the numerical
Yeah.
expression.
Right.
Yeah.
That's up
It has to
there.
be divided.
Right.
But you wanted to keep the same numerical expression, so you have to change what the number 4 represents. Number 4 in the first one represents pencils, number 4 in the second one represents students.
So Matt, say yours one more time. Everybody listen carefully. Maybe jot it down as he's saying it, if that helps.
I've got 12 pencils.
Okay?
I give to 4 students. How many pencils does each student get?
So I have 12 pencils that I'm giving to 4 students.
How many pencils does each student get? So I've changed the value of 4 from pencils to students.
Right. Right.
Okay.
The definition of 4, not the value.
Okay, and Dan, you started to say something. What were you gonna say?
No, I was just agreeing with him. I have
Okay.
kind of a similar one
Okay.
in what he's saying, but it's not the pencil one, but it's the same kind of thing.
Okay. Do you wanna
I
say
don't
it?
know. It's up to you, but Matt can agree or disagree, and that would help me out. But 12 horses get put into 4 trailers. How many horses are in each trailer? So that's like the 12. And then trying to keep the same expression. 12 horses get put into trailers, 4 horses in each. How many trailers were filled?
So you're looking for, in one scenario, we're looking for how many groups. In that case, it may be trailers. In this example here, we're looking for students versus the size of the group, in which case you're looking at how many horses can you put in a trailer, or how many pencils did a student get.
So does that kind of go with kind of how you're thinking? I was just trying to put my own framing, where you're keeping the expression in the situation, but the numbers represent
different
a
things.
different context of what's happening.
That center box there is showing us how our quotient is different. And that's, so the 12 is always our total, but the 4 and 3 have to swap meanings in order for our expression to stay the same. And so we're going to change our expression.
Matt, will you say yours one more time so I can capture it?
I have 12 pencils. I give them to 4 students.
Okay, so keep thinking to 4 students.
How many pencils does each student get?
Okay, so we're talking about the groups, right? So I really appreciate the conversation that we're having here, because again, this is really subtle in terms of those differences, but thinking about the fact that kids are going to be asked questions that have both of these flavors. Yeah.
I guess I look at that first one and it answers both questions though. 12 divided by 4 equals 3. Okay, groups. How many groups? Well, am I talking about the groups of pencils or am I talking about the groups of students? Okay, so this first one here is telling me that each student gets 4 pencils.
But you don't know how many students are getting those pencils. Over here, we know how many students are getting, but we don't know how many pencils they're getting.
Right, it's dispersing.
So just to define it depends on how you want to define what you're dividing it by to give you the group.
Right.
And that subtlety, again, whether you call it out as a naming mechanism in the classroom or whether you're giving multiple flavors of division problems in terms of helping kids make sense of that, I mean, that's up to you. Because again, we're working with whole numbers here, and we want to think about how this continues on into some rational numbers. Because by the time you're in high school, middle school, and high school, you're predominantly working with some rational numbers. So I dropped a question off with a few different groups and asked if there was another meaning of division that we might consider. Thoughts?
Other than what?
Other than the 2 we just talked about.
How many? So one of the groups
So what if you were walking around your classroom? Okay, so you could think about some repeated subtraction. But what if you saw
Divvying out, partitioning.
That's exactly right.
What if you saw that written on a student's paper?
Yeah.
Another way I was thinking about it, and just to stick with the pencils, if Matt's got 12 pencils and Jason has 4 pencils, how many times more pencils does Matt have than Jason?
Okay. Then we're making some connections there to the multiplication.
Yeah, the multiplicative inverse.
Yeah, absolutely, absolutely. And we want that tight connection between operations. Absolutely. So what if you saw this written on a student's paper? You just gave them the same question I gave you. What do you think they're thinking about?
Very low.
Mm-hmm. Yeah, that's my mistake. That's my mistake. So what might the verbal and the everyday life be that would go along with that? Okay. So tell me what's going on here.
Total square feet's 12, width is 4. What's the length of the room?
But still, square.
What's the length of the board?
The width is 4 feet. What's the length?
4 times something equals 12. So we know it's 3 because the expression is 12 divided by.
Yeah, absolutely. So
Question mark this time. Why is it a question mark this time if it wasn't on? Like I don't understand. I would see.
So I was just making a connection between here and here.
Right.
So this is 3.
But what the child would have in front of them is what we had,
Right.
which was an array of 4 by 3,
Yeah.
right? Okay.
So I initially, because I didn't see this, I was initially putting a question mark up there in order to draw the attention there.
Oh, okay.
Thoughts? I mean, I see some heads nodding. What's going through your mind right now?
Makes sense.
Okay.
With the numbers.
But I want us to also think about, so we've been talking a lot about groups and group size, but also thinking about the fact that, yeah.
What pops in my head is that typically I introduce area as multiplication. Once they understand that, then I'll flip it into division.
Yep.
But I don't see introducing the area with division.
No, and I wasn't necessarily implying that you should introduce area with division, but that when you're working on division problems, that there would also be some area type problems coming up.
Okay. To me, what we were talking about before was introducing division.
So this could be introducing division, absolutely. So if you're working in elementary school where division is being introduced, or where you're working with some division and you're introducing it in terms of rational numbers at the middle school, you could certainly do some of this work here. But you might also make a connection back to area, because this would be something that had come out in with multiplication at about 3rd grade, and then they start to think about how they would work backwards with whole numbers around area, 4th grade.
But if you, sorry, I don't know if we want to time this. If you're looking at area as 4 rows, you're really just going back to how many groups are in the 12.
So if you break this, so if you're thinking about it like an array, then you could certainly go into your number of rows and your number of groups. If you're thinking about it as linear dimensions, so that then this is a square dimension, so thinking about if I have 12 square feet, and I know the height or the length is 4 feet, what's the width, or vice versa. It may not be broken into foot by foot or 1 by 1. Because I mean that's one of those subtle differences between an array and an area model, is that we're thinking about linear dimensions that may or may not be those discrete pieces. Yep. I'm going to keep all of these right here together so we can keep thinking about them. I'm going to run out of room, aren't I? So just real quickly, take a glance back at those habits of mind and habits of interaction. Are there any more that we have worked with in the last little bit here that we hadn't already tagged earlier that you want to call out?
I think we had a good critique and debate going.
Yeah, absolutely. And what might have come out of the critique and debate?
Clarity.
Okay, so yeah, absolutely. So I would maybe call it making sense.
Yeah.
That we were really thinking hard about how those might make sense.
Genuine questions.
Yeah, absolutely. There's a whole lot of genuine questions. I mean, on all of our parts being asked. Anything else that you're... Well, we'll continue to come back to these because I want us to think about how they can come alive and be part of what's happening not only amongst us, but also as we go back to our classrooms and think about our work with our students. To help us kind of frame some of that, I'm going to ask you to turn to page 12 in your notebook. So page 12 and 13 are the student reflection tool, and there's pictures of the different habits of mind and habits of interaction. On page 12, the 3 big ones, make sense, justify, generalize, are at the top, and there's some verbiage underneath those to kind of make sense of what is being called out. And then there's the 6 other habits of mind coming down the left-hand side. On page 13, it's the habits of interaction. And there's a scale at the top of page 13 that ranges from a 0 to a 4, where 0 is hardly ever, never, hardly ever, all the way up to 4, which is just how you do math. I want to give you just a minute to think about yourself as a mathematician, not necessarily as a teacher of mathematics, but as a mathematician yourself, and just rate real quick. How often do you use these habits of mind and habits of interaction when you're doing mathematics? Don't forget the 3 big ones at the top of page 12. And then just in the little box to the next, to the different habits of mind and to the habits of interaction, I want to give you a second just to self-reflect. This is only for you.